So you've mastered solving basic trig equations, or at least you think you have. Up to this point, we've only been working with this domain of 0 to 2 pi, or just looking at the first rotation of the circle. But we know our circles are infinite. They don't just have one rotation of 360 or 2 pi. They can have an infinite number of rotations. And every time we make a new rotation, we come back on those same angles. We repeat back through those same x and y coordinates that make up our unit circle. So while you've been finding solutions with only maybe one answer, two answers, there actually are an infinite number of solutions for all of the equations you just solved. And that's where we're going to talk about this thing called the general solution. The general solution is saying, well, I know there is this repeating pattern. Every time we make a new circle, we're going to come across those same angles again, or coterminal angles. We're going to come across those same coterminal angles. So, is there a way we can generalize this? Is there a way we can write something out that says, well, it's this angle plus all the angles that match up to it, or all the angles that are coterminal to it? Well, that's what we're going to do. So let's take a look back at the first example we did together. We said the cosine of x is positive 1/2, which led us to pi over 3 in quadrant 1. Let's start there. Pi over 3 in quadrant 1 could just be pi over 3, or it could be a full rotation of 2 pi plus another pi over 3. It could also be 2 full rotations of 2 pi plus another pi over 3. Well, we could keep going. It could be 1, 2, 3 rotations plus another pi over 3. Are you guys catching on my drift here? It could be 4 rotations, 5 rotations, as long as we add a bunch of those 2 pi's and we still add that pi over 3, we're still coming back to this same exact terminal side. So there is a way to generalize this. There's a way to generalize, well, it could be 1, it could be 2, it could be 3, it could be 18. That's by saying, instead of 2 pi, 2 pi, 2 pi, 2 pi, 2 pi, or any number of 2 pi, we're going to say we need to have that pi over 3 angle plus any number n of 2 pi. I can add on any number of 2 pi's. This could be 0. I'm not adding on any 2 pi's. All I want is this angle pi over 3. This could also be the number 10,000. I mean, I'm taking 10,000 rotations of the circle and then adding pi over 3. That'll get us exactly where we want to be. So we have our pi over 3 angle right here. Let's check out 5 pi over 3 directly below it. So if I'm going from pi over 3 to 5 pi over 3, I've got this little rotation of pi over 3, this rotation of pi, and then this extra rotation of pi over 3. So this is kind of like a rotation of pi plus 2 pi over 3. So if you notice, this is not that same rotation. It's not that same size. This is a much larger angle than this one right here. So there's no regularity. There's no repeated pattern. I can't say pi over 3 plus 2 pi and get this one in the process. It's going to rotate right past that, and that's not what we want. We want to actually make sure we're encompassing all of the angles. So we're going to set up 5 pi over 3's own equation, its own separate equation. 5 pi over 3 is another unique solution, and every rotation of the circle is going to bring us back to that 5 pi over 3. So if we think about that, our first rotation of pi over 3, check. That gets us the cosine that we want. A full rotation plus an extra 5 pi over 3 gets us that rotation we want. We could even say that a rotation of negative 2 pi minus 5 pi over 3, or going backwards and then kind of tracking back on that 5 pi over 3 still gets us to where we need to go. So this n value right here can be anything we want it to be. It'll always line us up with that 5 pi over 3. So this would be our general solution. If you notice, it looks really similar. We've just added that any number of 2 pi, meaning every time we rotate around the circle, we're coming back to that same value. So let's look at the sign. The sign would look super similar. We have pi over 6 in quadrant 1 was that first solution we got. And 5 pi over 6 in that second quadrant was the second solution we got. If you notice, the connection between these two is much, much, much smaller than this right here. So there's not this kind of even spacing around the wheel or around the unit circle. And for that reason, we need to take them individually. First, I need to look at pi over 6 and say, well, pi over 6 is the angle plus any rotation of 2 pi, or any number of 2 pi rotations, meaning 2 pi plus pi over 6. 2 pi plus 2 pi plus pi over 6. Any rotation gets us back to pi over 6. Same would be true for 5 pi over 6. I could just have the angle 5 pi over 6. But I could also have the angle of 2 pi plus 5 pi over 6. Or 2 pi plus 2 pi plus 5 pi over 6. Or if we're getting really fancy, negative 2 pi plus 5 pi over 6. Any way you turn it, adding 2 pi gets us right back to those original two solutions. So if we're expanding this to be a general solution, meaning not just for that one circle, we would just say adding 2 pi. But let's check out what you did on screen number 11. And that involved tangent, where the tangent was -1. You should have found the tangent was -1 in quadrant 2 at 3 pi over 4 and in quadrant 4 at 7 pi over 4. This should look really nice to you guys. Hopefully you see this. These two angles together make a diameter, meaning there is a perfect rotation of pi, or half a circle, between them. So what this means is that I don't have to have two separate equations. I can say, well, let's look at 3 pi over 4. And let's kind of forget that 7 pi over 4 exists for a second. 3 pi over 4. I could add 2 pi. So 3 pi over 4, a full 2 pi. Cool, that'll get me there. But what about adding just a rotation of pi? 3 pi over 4 plus pi. That gets me to my 7 pi over 4. Well, plus another pi, I'm back to my 3 pi over 4. Plus another pi, 7 pi over 4. Plus another pi, plus another pi, plus another pi, plus another pi, plus 2 pi just gets me back here, plus another pi. I don't have to add a full 2 pi to get to another solution that has that tangent value that I want. I can just add any number of pi. And what that does is it encompasses these two solutions into just one. So the general solution for our tangent would actually be simpler. 3 pi over 4 plus n pi. And that's because, if you remember, they have this perfectly even spaced angle around the wheel. They're exactly halfway around the wheel from each other, or exactly pi around the wheel from each other. So if we kind of scroll back up to the sine and the cosine, we can't say that about either of these. So if you notice, this is not the same angle of rotation as this is. And back here on cosine, this is not the same angle of rotation as this is. For that reason, we can't just generalize it even further. We have to have two separate solutions to the equation, two separate solutions to the equation. But because this one is even, we can have just the one solution.